Hello, I'm Aaron Chow, and today I'm going to describe about my conic section project. A conic section is a graph that forms from a plane intersecting a double cone. The four main conic sections are the circle, the ellipse, the parabola, and the hyperbola. In a circle, the plane cuts parallel to the circular base. In an ellipse, the plane cuts at an angle between the outside surface and the circular base. In a parabola, the plane cuts parallel to the slant surface of the cone. In a hyperbola, the plane cuts through both parts of the double cone. In real life, conics exist all around the world. Some examples of a parabola you can see in real life are water spraying from a fountain, throwing a ball up, and the cables on the Golden Gate Bridge. Ellipses in real life include planets traveling in elliptical orbits around the sun, electrons orbiting the nucleus of an atom, ellipse shape parked in front of the White House in DC, elliptical water surface when tilting a cup, and cutting a fruit. Hyperbolas in real life include the sides of a guitar, the gear transmission, the Kobe port tower, and the hourglass. So here are some pictures of conics that I've taken. This is an ellipse-shaped bowl container. This is a parabola-shaped plastic Easter egg lid. This is a hyperbolic flower vase. This is a circular top of the lamp. This is a hyperbolic fancy table leg. So I chose to measure the ellipse, which is the bowl container. It's a horizontal ellipse, so it's x squared over a squared plus y squared over b squared equals 1, where a is greater than b. The major horizontal axis is 22 centimeters and the minor vertical axis is 17 centimeters. That gives us 2a equals 22 and 2b equals 17, which gives us a equals 11 and b equals 8.5. We plug those into the equation, and that gives us x squared over 121 plus y squared over 72.25 equals 1. I also chose to measure the parabola, which is the Easter egg lid. It's vertical opening downward, so it's x minus h squared equals negative 4p times y minus k, assuming that p is positive. 4 centimeters wide, so 2 centimeters on each side. 3.6 centimeters tall. Assuming that it's symmetrical with the y-axis, we get the vertex at 0, 3.6. So that gives us x squared equals negative 4p times y minus 3.6. It passes through negative 2, 0, and 2, 0. Plug in either point into the equation and solve for p. P equals 5 over 18. Plug in that into the equation again, and we get x squared equals negative 10 ninths times y minus 3.6. So I connected the conic sections into real life by identifying the lengths and vertices of the conic sections. These help me determine the position, shape, size, and dimensions of the different objects. So by that way, I can easily use this knowledge in the future to determine the correct objects that I need and to compare different objects by their measurements. Thanks for watching!